Rational exponents. You're going to love them. Rational exponents are rational, meaning fractions, but really a rational exponent is another way that we represent radicals. In other words, square roots. A square root is the same as a denominator of a radical. So let's look at an example. In this one, if we wanted to simplify this a little bit, we could do that by using our exponent rules to say that, well, exponent rules mean we're going to multiply these together. 6 times 1/2 equals x. 6 times 1/2 equals 3. So this simplifies just x cubed. Now, I want to show you the other way to do it, because what we can also do is we can treat the exponent of 1/2 as if it was a square root. Okay? Either way would still result in the same answer. So here we go again. We're going to go ahead and put this whole thing under a square root this time, because that's what a 1/2 does. A 1/2 as the exponent makes a square root. Then we're going to simplify this just like we would simplify square roots. So I'm going to simplify the numbers first. The square root of 81 is 9, and the square root of m to the 6th, well, 6 divided by 2 is 3. That's going to be 3 pairs. We can try to be a little bit more confusing by putting a number on top. Now, we can think about this like it's two separate things, okay? So the first thing I'm going to do is I'm going to go ahead and say, imagine instead it was 36 to the 1/2 to the 3rd, because that's going to give us the same thing as 3 halves. 3 1/2 is the same as 3 halves. And so if we were to think about it this way, then we'd say that the cube root, or sorry, the square root of 36 to the 3rd, and so this is going to be 6 to the 3rd, and 6 to the 3rd is 216. Now, we're going to go ahead and try to do this one. I want you to notice there's a negative there, but the first thing I'm going to do is I'm going to treat it like there's not a negative there. In other words, I'm just going to multiply the 64 to the 1/6, and I'm going to multiply the n to the 1/6, and that's going to make it 12 over 6. But then when I'm done, I'm going to go ahead and deal with the fact that we have a negative exponent. So we're going to talk about that at the end. First thing we need to do is we need to try to figure out if we can factor 64 until we have 6 pieces of the same thing. So I'm going to, over here, I'm going to write out my 64, and that's 2 and 32, and that's 2 and 16, and that's 2 and 8, and that's 2 and 4, and that's 2 and 2. And if I look at what I have left, I got 1, 2, 3, 4, 5, 6 2's. In other words, 64 is the same as 2 to the 6th power. Okay? So if I were to rewrite this just a little bit, what I end up with is 2 to the 6th power, but I'm also going to divide it by 6. And then n to the 12th power divided by 6. I'm going to simplify both of those, and I end up with, well, just 2n squared. Now, remember that we have that -1 that I've just been carrying around the whole time, okay? Now, you can deal with -1 at the beginning or at the end or at any point in between, but I just saved it for this very end because I wanted to remind you what that negative exponent does. What a negative exponent does is it flips the whole fraction, okay? So what was 2n squared is now 1 over 2n squared. We put it in the denominator. If it was a fraction, we'd flip the denominator and the numerator around, but in this case, 2n squared over 1, because it's not a fraction, we can flip it over and get 1 over 2n squared. Now, I want you to try this. You can do these in pretty much any order you want. So you can deal with the negatives right up front or at the end. You can deal with the cube root, and then you can square it. Or you can go ahead and you can cube something and then deal with the number on the bottom. So it's up to you. Thank you. Like and subscribe. Post any comments if you have any questions.